Okay, let's begin by talking a little bit about function notation. This is the way you'll see a function written. Y equals f of x. And notice I wrote it out here for you. Y equals f of x. It's important that you don't think of this right here as multiplication. This does not mean f times x, even though you see the parentheses. These parentheses are being used differently. Okay, so whenever you see, generally we'll use an F or a G, and you'll get used to when we're talking about functions and when we're not. But just be very careful to not confuse this with multiplication, because function notation is different than multiplication. Alright, so what is it if it's not multiplication? Well, you can think of it as maybe a factory, okay? So let's say we have a factory, not really sure, let's say a toothpaste factory perhaps. So we have this factory and it has a name, okay? You could call it any kind of toothpaste company, but this particular factory's name is F, okay? F is the name of the factory that's making toothpaste. And to make toothpaste, we need to have some kind of ingredients that we're going to buy, and we're going to work on those ingredients and turn them into toothpaste, right? So let's say it's mint flavored toothpaste, so you have the flavoring, you have the cleaning agents, okay, all of that is coming into the factory, right? All of these things, perhaps, we're going to call them X, whatever they are, they're going into the factory. Then the factory is going to mix those ingredients and package them and label them, and then they're going to send out their product, okay, send out the finished tubes of toothpaste. So every factory has some things going in, then the factory does some work, and then those things come out, okay? And that's the same thing with a function, okay? So the function has a name. In this case, f is the name of the function, and then it has some things going in, and they're the x's. And after the factory is going to do some work with those x's, then it's going to spit out an end product, and that will be the y. Okay, so this doesn't mean f times x, not at all. It means that we have a factory or a function named f. We're going to plug in some x's, and we're going to spit out some y's. So let's take a look at maybe an example of that. So if you have, for example, y equals f of x, this is the output, this is the function's name, this is the input, and then maybe we have a function rule, and the function rule is the part that tells us what our factory is making. If it's a toothpaste factory, or if it's a notebook factory, or whatever it is the factory does to the x's, okay? So this tells us, this 3x is called the function rule, it tells us what this factory does. Let's say we're going to, instead of putting in an arbitrary x, that means we don't know what we're putting in, let's put in something specific. What if we put in maybe a 4, okay? What is this factory named f going to do to the number 4? Well, it's going to say 3 times x, in this case x. We've replaced x with 4, so our factory is going to do 3 times, instead of x, it's going to do 3 times 4. Okay, so replace the x with 4, and we get 3 times 4, 12. And that's what this factory does. It multiplies by 3. No matter what input we put in, our output is going to be multiplied by 3. So we have the input of 4 and the output of 12. So our y in this case, our x that we plugged in was 4, our y ended up being 12. Okay, we put 4 in, we got 12 out. And we write that answer either like this, or a lot of times we'll write it as an ordered pair. This ordered pair means the input was 4 and the output is 12. So we'll write it like this in a nice little package that tells us what we put in and what we put out. Alright, let's look at some more examples. let f of x equal 6x minus 2. Find the value of the function f for x equals negative 3. So this is our function's name, f. This is the input x, and this is the function rule. This tells us what the factory actually does. Now the question says x equals negative 3. So into our factory, we're going to have an input of negative 3. Okay? So this is like instead of putting in mint flavoring, putting in strawberry flavoring, and all of a sudden we're going to have a whole new flavor of toothpaste, right? So we're going to put in a negative 3 and see what happens. So we'll copy down the function rule, but replace x with negative 3. Okay, 6 times negative 3 is negative 18, and then we have minus 2. Negative 18 minus 2 is negative 20. So when we have an input of negative 3, we have an output of negative 20. As an ordered pair, we have negative 3, comma, negative 20. What about in this case? Let g of x equal 5x minus 1 and find and simplify g of m plus 2. So in this case, g is the function's name, x represents the input, and our function rule is 5x minus 1. We want to know what happens if our input, instead of being x, is m plus 2. What's going to happen to the m plus 2? The factory, the function, is going to take that m plus 2, multiply by 5, and then subtract 1. So we will have 5, replace x with m plus 2, m plus 2, then minus 1. Okay, we can simplify this by distributing the 5. Okay, distribute the 5, so we get 5m plus 10, 5m plus 10, and minus 1. We can simplify by adding like terms. We can add the 10 and the minus 1 to get 9. Okay, so this tells us that if we have an input of m plus 2, we'll have an output of 5m plus 9. And as an ordered pair, that would be m plus 2 with an output of 5m plus 9. Find f of 2 for the function f equals 2, 6 and 4, 2. So what does this mean? In this case, we have the function name is f, and we're looking for an input of 2, but we don't have a function rule. Instead, we have a function listed in ordered pairs. So what this means is that this function consists of 2 ordered pairs, and they are 2, 6, and 4, 2. That means if you plug in 2 to the function, you get an output of 6, and if you plug in 4, you get an output of 2. So that's telling you for this particular factory, okay, we only can plug in 2 things, okay? If we plug in 2, we're going to get out 6. And if we plug in 4 instead, we're going to get out 2. But we can't plug in anything else. This factory only takes certain ingredients, okay? It's not available for everyone. It's pretty exclusive. So if we plug in, the question's asking again, let's go back to it, f of 2. Okay, if we plug in a 2, we're going to get out a 6. If we try to plug in a 4, we'll get out a 2. But if we try to plug in anything else, the function or the factory will explode, okay? It doesn't work. It won't take those ingredients. It will reject them. But in this case, we're good. So 2, 6, 6 would be the answer. What about if we have a graph? Refer to the graph of the function. Find f of 2. So here we have our graph. Remember, we can say that f of x equals y. So in this case, what we're saying is that x equals 2. What does y equal? Okay, that's what function notation means. It means that x is 2. Okay, see how x is in the parentheses, 2 is in the parentheses. So what does y equal? So if we go to 2 on the graph, it's a little bit fuzzy. We can come over to 2, okay, and then we're going to go up to the graph, and the graph is right here. So when we're at 2, we're right here. What is the y value of this? The x value is 2, the y value is positive 1. So when x is 2 on the graph, y is 1. So we have the point 2, 1. Alright, awesome. What about find f of negative 2? That means that x is negative 2. What is y? Okay, x is negative 2, so we'll go to negative 2. Where's the graph? Is it up or down? Okay, it's up here. And what's the y value for this point? Y value at negative 2 is 3. So when x is negative 2 on the graph, y is 3. Alright, great. So now let's do the very last one. This says for what x value is f of x 0. So look at, we have f of x equals y, so this is saying f of x is 0. That must mean that y is 0. The output is 0. We want to know, if we need an output of 0, what input should we plug in to get that 0? Okay, so let's look at the graph. We know that in this case, y is 0. Okay, so where is 0 on the y-axis? Alright, and where is, if we go over to x would be right here. Okay, so the graph crosses right here. So x would have to be 4, 1, 2, 3, 4, for y to be 0. Notice this is an x-intercept. Okay, so we have the point 4, comma 0. If we plug in a 4, if our input is 4, our output will be 0. Rewrite the equation using function notation. Okay, we'll have 2 steps to do this. Basically, if you keep in mind that f of x equals y, it will help you do this. The first step is we're going to solve for y. Okay, and then we're going to replace y with f of x. So solve for y, we can, let me write down the equation first. We want to get y on a side by itself, so we can subtract negative x squared from both sides of the equal sign, get negative 4y equals negative x squared plus 3. Alright, and then secondly we can divide by negative 4. Okay, divide, make sure to divide every term, or you can think of it as dividing both sides of the equal sign. So y equals positive, because the 2 negatives cancel out, 1/4 x squared minus 3/4. Alright, and then the second step, this is almost function notation. Okay, this is a quadratic. You've seen equations like this before, but in place of y, because y equals f of x, we're going to replace y with f of x to put it in function notation. So f of x equals 1/4 x squared minus 3/4. And f is our function's name, x is the input, and then over here we have the function rule. So this will be function notation for this equation. Okay, and lastly, I just wanted to show you this. You've seen this before. You know the slope-intercept form of a line is y equals mx plus b. Sorry, let me erase the a. Okay, mx plus b. This is the exact same thing, okay? For function notation, we just write it differently. We have f of x. Remember that y and f of x are the same thing. Think of f of x as one unit, okay? It's the name of the function, including the input, but it is not f times x, and so you should think of it as one thing. Y, f of x, they're the same thing. And then we have a, x plus b. You can see that the x, the plus, and the b are the same. The m and the a are different, but it's just different notation. The a is the same thing as the slope, just like m. And so this is just another way to write lines, but using function notation. So if you were going to graph a line in function notation, for example, if you had the line g of x equals 1/3 x plus 2, you would graph it using the y-intercept and the slope the same way you would graph it if it were y equals 1/3 x plus 2. Okay, same thing, same thing.